Okay, so we'll start with trigonometry. In trigonometry, then we'll do a bit of exponential, then we'll do binomial. So we are now on trigonometry. In trigonometry, the first thing that we need to know is what type of functions that we're going to be dealing with. What functions are you going to be dealing with? The first function is the sine function. Okay, the second function is cosine. The third function is tangent. So with these functions, they move with functions like cosine, which is 1 over sine. We have functions like sec, which is 1 over cos. We have functions like cot, which is 1 over tan. These are the functions that we'll be talking about. So tan also can actually be written as sine over cosine. Okay. So if sine can be written like that, then cot can be written as cos over sine. So this means that then to understand the whole trigonometry, what one needs to do is just to understand sine and cosine. Because out of sine, we have cosec. Out of cosine, we have sec. Sine and cos combination gives us tan and cot. So then if I know the behavior of tan, the behavior of cos, then I would have known so many things. That said, we need now to know how sine and cosine relate. So the first relationship, that is called an identity, is that if you square sine, square cos, the sum is going to be 1. This is the most important identity. It's very, very important. If you square sine, square cos, you get the sum, it will always be 1. Such that even if I say sine squared A plus cos squared A, it should be 1. So what I mean here is whatever angle I put in, the angle does not matter. For as long as I've squared and it's the same angle, the identity holds. So you keep that in mind. And then, have you seen that just when you move from the functions, we start talking about angles. Then we need to know what angles and what values we get when we use what angles. That is very, very important. What values do we get after using what kind of angles? So we have what we call the quadrant. what we call a quadrant. So we have the first quadrant, the second, the third, and the fourth. The first, an angle that runs from 0 to 90. The second, from 90 to 180. The third, from 180 to 270. And the fourth, 270 to 360. I've put these angles in degrees, but angles can also be studied in radians. The conversion we have from degrees is that, well, if you're in radian, it is called pi. In degrees, it's called 180. Okay? So if you're in radian, it's called pi over 3. If you're in degrees, 180 over 2 is 90. Okay? Here, it's called 3 pi over 2. The other side is called 270 degrees. You have 2 pi. The other side is called 360. The only thing that appears the same is 0. 0 is still 0 even in degrees. So you can convert any angle from radians to degrees, provided you remember that pi equals 180. For example, if I have 2 over 3 pi, and I'm told to convert to degrees, the only thing I'll do is that I'll write 2 over 3, and where there is pi, I'll put 180 because I know that 180 is equivalent to pi. So I will divide 2 here, 1, 2 there, 3 there, 6. So we have 120 degrees. If I'm given 780 to convert to radians, what I'll do is I'll multiply radians divided by the degree, 180. So I'll have pi of 180. So that the 180 can help me get rid of the degrees. Like that. So then I can now divide 2 here, 9. I have 2 there, 39. So 3 can go again. 3 there, 1, 3 there, 3 over 3 pi. So I've converted from degrees to radian. So that's what you do. So in converting 2 over 3 pi to degrees, we simply did 2 over 3 and then multiplied 180 over pi because there was a pi here. So you can divide this pi and this pi, and then you divide now that, so you get 120. That's how you convert from degrees to radians. It's very important, this one, because you find questions that are given in radians, and then if you're not comfortable, so you have to convert and work with what you're comfortable. In most cases, we can't even tell whether you had changed to degrees or to radians, because maybe we're asked to find the value of sine 270. If you're comfortable with radians, even if you write the sine 3 pi over 2, what will matter is the solution. That's what's going to matter. Okay, so the first thing should be checked conversion. So we can convert from radians to degrees and degrees radians. So if you are able to convert them well and good. Okay. The second thing is that in the quadrants, when you get all these angles, all the angles that are between 0 and 90, and substitute in any of those functions, be it sine, be it cosec, be it cos, be it sec, tan, or cot. Any value from 0, between 0 and 90, you can get a calculator and start punching any number between 0 and 90. The values you'll be getting will all be positive. If you pick a number between 90 and 180, the only function that will give you positive will be sine and cosec. The other functions, tan, cot, cos, sec, these are going to give you negatives. I have my calculator here. For the sake of checking, if you want, you should check tan. Where is it? Tan. Here I've put tan. I want to put 91. Tan 91 is negative 57.2. Okay, you can put any value. Let me now go for cos. Cos 93. It's negative 0.05. So any angle that is between 90 and 180, the only function that gives positive values are sine and cosec. The rest you get negative values. In the third quadrant, we only have tan and cot. These will give us positive. The other ones, cosec, cos, sine, sec. These will give us negative values. In the fourth quadrant, we will have cos, sec. Only these two will give us positive values. The other ones, sine, cosec, tan, cot, they will give us negative values for the angles between 270 and 360. So this is about quadrants. Then now we want to add information on the same quadrant, information that has to do with, since we have known which angle sits where, now which ones do we know the values for, even without using a calculator? You've seen here I was punching sine, cos 91, sine 93. Are there values that we can tell without a calculator? If so, how? Okay, so we talk about special angles. So we have special angles for sine, cos, and tan. So we have special angles 0, 30, 45, 60, 90, 180, 270, 360. So we can put everything here, sec, cosec. So I'll put also sec, I'll put cosec, then I'm going to put cot. So we'll demonstrate, we'll find for sine, cos, and tan for all the special angles, and then the remaining ones, you just sample which one to demonstrate, and then you guys can finish up. So let's talk about the first ones. So on the quadrant, we have 0, we have 90, we have 180, we have 270, we have 360. Now we want to pick a unit circle. So we put a unit circle here. Unit means that the radius is 1. Now on the x-axis, if x is 1, well, we know that on the x-axis y is 0. So I'll put it as 1, 0. On the y-axis, it will be 0, 1. This side, it will be -1, 0. And this side, it will be 0, -1. Why are we saying 0, 1? Because, I mean, on the x-axis, y is 0. On the y-axis, x is 0. That's why you're seeing the 0 start, the 0 start for the other one, the zeros are in the second coordinate for the other one. Now, sine, I mean, the x-axis is cos, and the y-axis, and the y is sine. So we have cos, we have sine. So we have cos, we have sine. We have cos, we have sine. So we have this cos, sine, cos, sine. Now let's get to the table. What do you mean by cos, sine there? So, okay. So we have for 0, cos 0 is equal to 1. That's what the 1, 0 means. So cos 360 again is equal to 1. So sine 0 is equal to this 0 here. So sine 0 is 0. And sine 360 is also 0. Then sine 180, where is sine 90? 90 is here. Sine 90 is 1. So sine 90 is 1. And sine 180 is 0. That value there. Sine 270 is -1. Okay. So the remaining coordinates are for cos. So cos 0 is 1, cos 90 is 0, cos 180 is -1, cos 270 is 0, and cos 360 is 1. So if we know, then we can tell that, oh, tan 90 is sine over cos. Because cos is 0, sine 90 is undefined. Because 1 over 0 is undefined. But sec 90 again is undefined because of cos that sits in the denominator. Cosec 90, that would be 1 over 1, so that is going to be 1. And cot 90, cot 90, remember cot is cos over sine. Because cos is 0, cot is going to be 0 at 90. So this is what I mean by demonstrating on the other ones. Okay. So now, tan 0 is going to be 0 because that is 0 over 1. So we want to move to 30, 45, and 60. Now to 30 and 60, we start with an open triangle. This triangle is isosceles. The sides are equal. Now, if the sides are equal, then even the insides, the angles must be equal. So when the angles are equal, and then we decide to come here and cut, it means we have formed the eight. And what was 60 is now 30 this side, 30 that side. So even the distance which was 2, it's now 1 this side, 1 this side. Then Pythagoras theorem tells us that, or if you want to find a missing side, like the one in between, if you square the hypotenuse, you should get the same thing like adjacent squared plus opposite squared. Now we have hypotenuse here to be 2. Adjacent, the one that is known is 1. And then opposite, we don't know. That is 4 minus 1 equal to opposite squared. So that opposite squared is equal to 3. So opposite is equal to the root of 3. So we have root 3 here. Right. So what does that mean? We now know from Sokato. We can tell what. Now we can tell what. We can tell what sine 30 is. What is sine 30? Sine 30 is opposite over hypotenuse, which we have. Sine 60. Sine 60 is opposite over hypotenuse. Cos 30 adjacent of hypotenuse. And cos 60 half. We're remaining with 45. 45 also has its own triangle where the sides are equal, the adjacent and the opposite. And this is 45, meaning even there it's 45. This justifies why we're saying these two angles are equal. Then now if you square the side, we get 1 squared plus 1 squared, that's 2. And then the root of 2 becomes the hypotenuse. So now we want to talk about cos, sine 45, it will be 1 over the root of 2. And then if we rationalize, we're going to get the root of 2 over 2. So we'll have root 2 over 2, which is the same value even here. So we have that. And then now we can talk about tan. Okay, tan opposite over adjacent. So this is going to be 1 for 5. The other one, opposite. Let's go to 60. Tan 60. We took opposite over adjacent. That's root 3 over 1. And then the other one, opposite over adjacent. That's 1 over root 3. The same SOHCAHTOA can also be SOHCAHTOA, except for for the tau. So when I write it like this, I want to mean when you come for cosec, when you come for sec, and when you come for cot, those will switch. They will switch. Okay. Now this is mostly used in Zimbabwe. For here, we just go direct here and then we use the normal one. So now for sec, cosec, and cot, you can fill up by just for sec, we are saying it's 1 over sec is 1 over cos. So we are picking using these values 1 over cos. So it will be 1 over cos, that will be 2 over root 3. 1 over cos, that will be 2 over root 2, which is just going to be root 2. And then here, this is going to be 2. This is going to be -1. This will be undefined. And then this will be +1. So you can fill up cosec and cot. These are for you to fill up. So now these are the special angle values. Now, how many special angles do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Only 8. That doesn't mean that these are the only angles that we have. We have so many angles. But then some angles will be rated to these. So those that will correlated will also be able to find their values. Those who correlated will also be able to find their values. So these were special angles. Now we want to bring in the angles which are reference to the special angle. Angles that are reference to the special angles. So we go back to the quadrant again. We say this is 0, 90, 180, 270, 360. We have identified 3 angles. We identified 45. We identified 30. We have identified 60. These are the special angles and they lie in the first quadrant. So there are other angles in these quadrants which are related to those angles then. Okay, so these angles 30, 45, 60. If you go in the second quadrant, there are angles that when you subtract from 180, they will give you these 60, 45, and 30. So we want to call these angles that are here, let's call them theta. So if I want a theta in the second quadrant, from the angles that lie in the second quadrant, I can just subtract those angles that lie here. I subtract from 180, I'll get my theta in the first quadrant, meaning I'll get 30, 45, and 60. If I have an angle here, I'll subtract that very angle I have here. I'll subtract 180 from them. And then this side, I will have 360 minus the angle that I have in each quadrant. Okay? Where theta is a reference angle. some situations will force us to now want to get the x, where you are given a reference angle and you want to find an angle that lies in the fourth quadrant or in the second or third. So that way you were solving for this. So get x to be 180 plus theta if you're in this quadrant. Here, x will still be 360 minus theta. Here, x will still be 180 minus theta. So those are cases when you are solving some equation and you find, let's say, cos theta is equal to whatever, maybe half, and then you get that theta is 60. Okay, but then you know this is in the first quadrant. I can also find one in the fourth quadrant. So you go there and say, okay, one in the fourth quadrant should be 360 minus 60. So that is 300. So I can get a bigger angle from the smaller one. And I can get a smaller angle from the bigger. So these are movements from a small angle to a bigger, or a big angle to a smaller one, are what we are referring to as the relationship of reference angles. So now the angles that are sitting in each quadrant, for example, what is the value of cos 150? So this, because we don't know 150 as a special angle, we will use the reference angle of 150. So we'll say, oh, we're going to deal with cos 180 minus 150. So this is going to be cos what? It's going to be cos 30. But hey, 30 is coming from the first quadrant. And 150 is coming from the second quadrant. So where cos is negative. So here you must put negative cos 30 because 30 itself cannot give us a negative because it's coming from the first quadrant. This is where now we start thinking. Okay, so I'm given an angle in the second quadrant. I don't know whose value it is, but now I need to look for an angle which can help me get the value. Now this angle I'm given is 150. So I can subtract it from 180 and get 30. But if I use 30 in cos, I'll get a positive value. But then I must remember that the 150 is in the second quadrant where cos is negative. Then I put a negative. The value I get after getting the cos 30 value. Then I put a negative. So that's how we're going to be appreciating the reference angles. A quick one is the coterminal angles. Coterminal angles, again, on the quadrant, we define this angle A to be coterminal to this angle B. So we say A and B are coterminal if they share the same starting point and end point. And if A and B are coterminal, then sine A is equal to sine B. Cos A is equal to cos B. And A is equal to tan B. Cos A is equal to cos B. Cosec A is equal to cosec B. Sec A is equal to sec B. So coterminal angles gives us the same value. These are angles that share this starting point and they also share the end point. These have same values. I hope that's fine. Okay. So now I'm giving you a task that you're going to sleep with in the homework. This thing that we have done here, we have talked about the quadrants, about which trig function is positive where and negative where. Two, we have also talked about the conversion from radians to degrees. Then we've talked about special angles, the values. We've talked about the unit circle in terms of the angles on the axis. We've talked about the reference angles, and I've explained the coterminal angles. So these angles that we've talked about now, I want you to make sure that they make, Karen, I want you to make sure that they make sense. So you know how we're obtaining each reference angle. You know how we're obtaining, how we are appreciating the reference angles in the first quadrant, those in the second, those in the third or fourth. Get that and then answer the tutorial sheet question 1. It's a table that is almost an extract of this table here. So if you look at that question, it's coming from here. So answer question 1, and then also answer question 2, because question 2 is on the quadrants. It's talking about the quadrants. And so cut off. So you try to answer them. And then tomorrow again, we have a class where now we talk more of the type of question 2, and then bring in identity so that you can answer questions that are coming down. So you have it.